Welcome back. This is the second video for Chapter 6, Design Using Methods. And today what we're going to do is talk about top-down design. Top-down design is an iterative divide and conquer technique for solving large problems. And so the idea is, if you're confronted with a really huge problem that you can't possibly solve, you just feel lost, you don't know where to start, what you try to do is divide that really large problem into smaller problems. May still be too big to handle, but at least they're smaller than the original. And then, ultimately, you divide those into smaller problems yet that you can conquer. Okay, so you try to take a big problem, divide it into little pieces, solve the pieces. So if we look at that graphically, let's let this box here represent our problem. It's too big to handle, too much for us, so we're going to divide it into subproblems. And perhaps the subproblem on the left is still too big, so we're going to divide that problem up into sub-problems, which will be easier to understand. Okay? And then we would solve each of those independently, solve this subproblem, this sub-subproblem, combine their solutions together into a solution for this problem, solve this subproblem, combine those solutions together, and now we've solved our whole problem. Okay? In terms of software, we might think of a large program as the problem we're trying to solve. We would divide that into methods, and then if those methods are too big, too hard for us to understand, we would divide those methods into submethods. Okay? Well, a natural thing to wonder is, when would we stop? How do I know when I've gotten my methods small enough, or my subproblems small enough? Well, an obvious answer is when you think you can solve them, but there are some other rules that we can use to determine when a method is small enough. So, first of all, make sure that every method that we write should only do one thing. It should have a single purpose. And if it does more than one thing, then maybe we should decompose it into smaller bits. If you're having a problem naming your method, then that's probably a good sign that you could decompose it into sub-methods. It's also a good sign that you haven't done your design work because you don't understand what you're trying to do yet. Related to that, if your name for your method has the word "and" in it, or if it has the word "or" in it, that might be a good indication that your method needs to be decomposed into submethods. Okay? So a rule of thumb. Try to limit the methods that you write to one screen or one printed page in length. That way they'll be easy to understand, and you can approach them and understand them easier and code them easier. Okay? Ultimately, top-down design is going to be beneficial for other reasons. It helps us to make major design decisions early on in the process. So with our processing programs, it'll help us decide which methods we need to write. Like a simple example is, do I need a key press method? Do I need a mouse moved method? Do I need a mouse clicked method in this particular application? A top-down design approach would give us those answers. This is sort of an old technique. So once you become more proficient at programming and move on to other classes and work on other designs, you won't be using top-down design for entire programs. Instead, we'll be doing what's called object-oriented design in that case. But this technique still applies. That is, we've got our overall program. Now how can I partition it, divide it up into classes and objects that we'll need to use to make the program work? So the technique, even though we won't be doing hierarchies of methods forever in our programs, the idea of top-down design still is valid. So the bottom line, there are some epigrams at the beginning of the chapter. How do you eat an elephant? One bite at a time. And cry in the dojo, laugh on the battlefield. The idea is to make sure that you do your design work ahead of time. You decompose your problems into smaller subproblems, and things will be much easier. Okay? In our next video, then, we're going to start looking at the solo Pong example from this chapter. See you then.